Sumeet, episode 24. I'm Neil.
And I'm Richard.
This week we got a really special treat for you. We got a chance to sit down with Sumeet from Presto Labs, and what they're working on is a gesture-based system that uses your Android smartwatch. So let's just jump into it and take a look at the first demo.
Hey Sumeet, thanks for coming on the commit.
Thank you.
So tell everyone a little bit about Presto.
So Presto is a library that does gesture detection on your Android Wear smartwatch.
Okay.
So if a user snaps their fingers or flicks or does other hand movements while wearing an Android Wear smartwatch, we detect that and send events to either the
So
device,
just by the software?
just by the software.
Right, so no specialized hardware needed. I can run this on any Android watch.
Exactly.
Awesome.
And you can actually get the events, the event callbacks into your Android Wear device, or you can get it, or the event callbacks go into your paired Android phone.
Awesome, I want to see this working.
Great, yeah. So we have an app out there. One of the most compelling uses of gesture is to control music.
Right.
And we have a reference app out there called Presto Music that's built on the Presto library.
Okay.
And I'm just going to start Presto Music. Once the Presto Music app is installed, all you have to do is start Spotify. So I'm going to start Spotify now.
Okay.
And when I do and start my music, it's going to activate my gesture on my watch.
Okay.
And then to control the music, I do a gesture and I raise the volume.
Wow, that's incredible.
I can also lower the volume.
Amazing.
And the other things that I can do are I can do a gesture to, go to the next song. So that the next track just came on.
Incredible.
And you know what? I think the demo's over now, so I'm just going to snap my fingers to stop the music.
Bravo, I'm impressed.
All right, Sumeet, so we talked a little bit about the Android version of the SDK. What can we do with Unity in VR?
Yeah, so as we've spoken to lots of developers in the field, we found that VR developers are very interested in getting input. It's one of the harder problems that VR developers are facing today, how to get user input. And so we believe we have a really good solution for that. The gestures that we recognize on Android, we can also pass them on to a Unity project. So we have a plugin available on the Unity store which you can drop into your project and get gesture events into your project. So
cool.
Maybe we can do a quick demo.
Yeah, let's take a look.
Okay, so this game is built using Presto's Unity SDK, and what it is a ball that you manipulate using gestures. And the idea of the game is to touch the coins using the ball. So as I move my hands left, the ball is going left. As I move my hand right, back, the ball is coming closer to me.
Oh, sweet.
Now the ball is going further away from me, and and I can make the ball go right by turning my wrist like this, and I can eventually I can also make the ball go back to the origin by flicking like that, and make the ball jump in the air by snapping like that.
Sweet.
And so that's how I basically collect some coins.
Cool.
Yeah, so that's the game. If you like, I can dive into the code.
Yeah, let's take a look at some mono-developed code.
All right, awesome. So let's switch to the code here. So essentially, the ball that we were controlling is controlled by a script in Unity called Player Controller, and you see the various functions on the Player Controller code here. Right at the beginning, there's a function called start, which we use to initialize. In the start function, we are setting up all the gesture events that we care about, and specifying what functions in this script should be called when those events are received.
Cool. So you got listeners for snap events, tilt events, flick, and twist.
Exactly, that's right. So the twist event, what it does is it makes the ball just dead stop. So the code here is it sets the rigid body velocity to a vector of zeros. So basically, if you twist, the ball is just going to stop wherever it is. The tilt events, so there are two kinds of tilts that Presto sends events about. There's tilt in this direction along this axis, and there's tilt along this axis. So we get, the functions are previous tilt x and this tilt x, and previous tilt y and this tilt y. And so what we're really doing, we're using this to move the ball around in the two-dimensional plane in the demo that we just saw. And really what we're saying is take the x and the y and set the velocity in the two dimensions that we've got. Set the velocity in the upward direction to 0. So, and then just and so basically, as you move your hand in this direction, that moves the ball in the two-dimensional plane.
Cool. And so that's constantly updating every time you make one of those events, and so that way you can sort of keep the motion going.
Right. Exactly. So we get an event every 9 degrees. So this is +10. This is so as you come down 9 degrees, you get an event every 9 degrees.
Cool.
And same for this in 9 degrees.
Right. And so obviously we were keeping it in the same plane before, but then on the snap event, you'll actually jump the ball up.
Exactly. So so to do that, what we do is we create a 3-dimensional vector. We set in the plane that the ball was moving, we set the values to 0, but in the upward, the y direction, we set a force of 800, and then we just add a force to the ball when we get a snap event in the snap function. That makes the ball jump up when you snap.
Cool. And then you let physics take over.
Exactly. I mean, Unity is really great for having all the physics engines built in, and so you don't have to worry about all that.
Cool. And then the flick event sort of brings you right back to center.
Right, so you saw the flick brought you back to the origin and kept the ball still. So what we've done here is we've created a 3-dimensional array vector with 0 in the x and 0 in the z direction, and the y direction is 0.5 because we don't want the ball to be half sunken.
Yeah.
We want it to be like above the ground. So, and then we basically transform the position of the ball to that vector, and we also set the velocity of the ball to 0.
Cool. And it looks like you also have one last function to provide some haptic feedback,
Right.
so that when you trigger a specific event,
Right.
you can sort of have the watch actually vibrate.
Exactly. So this is so most VR developers will tell you that it's good to give users some feedback when things happen in the VR program. And one way to do that is haptic feedback. But if you do haptic feedback on the phone, it's going to make your head vibrate, and that's not very friendly, I think. So what we do is we have a function that allows you to give haptic feedback to the watch. You specify a pattern that allows the watch to vibrate with that pattern. And so what's happening in this case is we have a trigger that happens when two objects collide, and we make sure that if the collider is a target object, which is a gold coin in this case, we actually create a pattern, and we send that pattern using the function send haptic feedback to watch with the pattern. In this case, it's going to vibrate for 500 milliseconds, pause for 100 milliseconds, vibrate for another 500 milliseconds.
Cool. And so if you go to presto.watch, you can get this code and get this library?
The library is available on the Presto Unity asset store. The instructions for how to use it are on presto.watch. There's a quick start guide for Unity developers. There's a link for Unity developers. You should be able to get an app up and running in about 30 minutes, a rudimentary gesture control app in Unity up in about 30 minutes.
I feel like that's a challenge. I want to see some new Presto apps now.
Hope so.
All right, thanks so much for showing us through the VR app.
Thank you.
Hey folks, for this week's Staff Picks, we've got 2 projects from the Wacom Inkathon. Really cool online hackathon that closed recently. My project is Dragon Story. Neil, this is a really, really beautiful submission.
It really is.
And the idea is that it's for children to draw in the app to solve the puzzles and win the game. So you can see here you have to draw a boat to get across the piece of water. You then have to draw a sword to fight the dragon. I really love this. It's so fun, great use of the technology, and I think you could, as you were saying earlier, you could really see how you could extend this, right?
Yeah, you could do a whole book's worth of stories, and you could have cutscenes and have them just animated, and have people have to do key actions along the way. It'd be really cool.
It's really cool, awesome job, and obviously won the Popular Choice Award in the hackathon as well. So really cool project. What did you pick?
Cool. So I picked Sincerely, which actually allows you to use the API from Wacom, the ink layer language, sort of like digital ink, as well as Clarify's API for machine learning to basically train a machine learning algorithm to recognize your own signature. So you can actually go into sort of this HTML canvas and say, okay, this is one version of my signature, here's another iteration of it, maybe train a few versions of it, and then you could actually sort of challenge it and say, well, okay, maybe I get someone else to write my name and my signature, and you can challenge that against it, and it'll tell you whether or not it thinks it's a genuine signature. So
Amazing.
kind of a really neat use of Clarify Imager to sort of host the images that you create, as well as the ink layer language.
And created by a friend of ours as well, right?
Yes, absolutely. A couple friends of ours.
That's so cool. Awesome. Good job. Well, we'll be back next week, and exciting week for us next week, filming the first commit that we're going to actually film off-site here. It's going to be at Penn Apps. So if you're at Penn Apps and you want to be on the commit, come say hi. Happy hacking.
Happy hacking.